Hello friends, my name's Nikhil Jain. I am a civil structural engineer. Today I will discuss about an example of G+7+terrace story building analysis and design using 3D space frame analysis and design software. This is AutoCAD plan of the building. Building is 9 meter by 6 meter and height is 27 meter. On every floor, there is 6 room, each 3 meter by 3 meter. You can enter data as per your building plan and requirement. First sheet is input data. In this sheet you have to enter data in light yellow cells. First enter node data. This is node number, its x coordinate, y coordinate, z coordinate, and support condition, fixed or release. Second enter node load. This is x force, y force, z force, x moment, y moment, z moment according to node number. The node load sign is positive for positive x, y and z direction and negative for negative x, y and z direction. Third enter member property. This is beam and column section name, width, and height in meter according to section name. Fourth enter material property. This is FCK compressive strength of concrete 20 and Poisson ratio 0.25. Fifth enter total number of member is 261, total number of node 120 and name of vertical section is column. You have to enter appropriate data. Sixth enter member data. This is member number, start node I, end node J and section name, column, or beam. You have to enter appropriate data. In that if you entered wrong data like I node is larger than J node, error message will be display. Click OK corrective. Enter I node smaller than J node. Seventh enter member load data. This is uniformly distributed load UDL in kilonewton per meter. Its location in the form of A, B and C. This is point load P1, P2, P3, P4, P5 in kilonewton. Its location in the form of A, B, C, D, E and F. Here I have no point load. This is as per drawing. Eighth enter angle of roll in degree. In that enter 0 or 90. If column position change its angle then enter 90. I have no changes in column position, so keep it 0. Ninth enter type of beam. In that, if beam is cantilever then select option start node I cantilever or end node J cantilever. Otherwise keep cell blank. I have no cantilever beam so keep all cell blank. 10th click reset or clear button. All previous result data will be cleared. 11th click on analysis button. Keep in mind that before analysis started all other program shall be closed, so analysis take less time to complete. Your analysis is start. Analysis will take 5 minute, 10 minute to 30 minute or 60 minute or more depends on number of member and number of nodes. As analysis is complete. Analysis completed successful, see member end forces, displacement, reaction message is display. Wait for this message then and then only analysis is completed. Click OK your analysis is completed. Same analysis is done for dead load, live load, earthquake load, and wind load separately. Next go to load combination sheet. Click on reset or clear button. Your previous project data will be blank. Next click on member end forces for dead load. The same procedure is followed every time for member end forces for live load, earthquake load in positive X, positive Z, negative Z, wind load in positive X, positive Z, and negative Z. In this way your all result data will be saved in load combination sheet. This is all result data I analyze and save for dead load, live load, earthquake load in positive X, positive Z, negative Z, wind load in positive X, positive Z, and negative Z. Second sheet is model. In this sheet you have to click on draw model button. Save the sheet. Your model will be displayed as you enter model data. You can rotate model. You have to enter alpha angle, beta angle, and gamma angle. Click on Draw Model button. Save the sheet. So in this way you can see top plan view, bottom plan view, front elevation, back elevation, left side elevation, right side elevation and 3D perspective view. Sheet is earthquake analysis. In this sheet you have to enter data in light yellow cells. First enter number of story is 9, including first floor to terrace floor, ground floor. Second enter type of building. I choose residential and commercial buildings. You can choose any one appropriate to your building. Third, choose that building is moment resisting RCC building with brick infill panels or building is moment resisting RCC building without brick infill panels. I choose first option, moment resisting RCC building with brick infill panels. Fourth, enter location name. I choose Surat. In that you have to mention city name in which structure is located. Fifth, enter building system. In that many option available like RC building, steel building, masonry building, braced building. I choose RC buildings with special moment resisting frame SMRF. Any option you can select. Sixth, enter soil type. I choose medium stiff soil sites. You can choose any one available of them. Seventh, enter floor area. My building is 9 meter in X direction and 6 meter in Y direction. You have to enter your building plan dimension. Eighth, enter total seismic weight of the structure W in kilonewton. It is 9,179.391 kilonewton. Ninth, enter height of the building H in meter for earthquake load in X direction. It is 27 meter in my case. 10th, enter height of the building H in meter for earthquake load in Y direction. It is 27 meter in my case. 11th, enter story name. I enter ground floor, first floor to 7th floor and terrace floor. 12th, enter W, weight of floor in kilonewton. In that live load on terrace and above terrace need not to be considered. For live load up to and including 3 kilonewton per meter square 25% live load to be considered. For live load above 3 kilonewton per meter square 50% live load to be considered. This is total beam dead load and percentage of slab live load. 13th, enter height H. I enter height of that floor in meter. Next, click on reset or clear button. Your all previous result data will be blank. Next, click on output button. Lateral earthquake force at all floor level in X and Y direction will be displayed in kilonewton. Fourth sheet is earthquake nodal load. In this sheet you have to enter data in light yellow cells. First, enter particular floor member number, uniformly distributed load, its position in the form of A, B and C. Then enter point load P1, P2, P3, P4, P5, its position in the form of A, B, C, D, E and F. Then enter member length 3 in meter. Then enter total number of member on that floor. It is 29. Next, click clear or reset button. All previous output data will be clear. Second, as seen in grid, from top left corner give column number and beam number around that column. If any node load is there, you have to enter that data also. You can see data as I enter for my building. Column number 1, around that column beam number 13 in X direction and beam number 22 in Y direction. If no beam in other direction, then enter 0 in that direction. Then column number 2, around that column beam number 13 in minus X direction, then beam number 14 in X direction and then beam number 24 in Y direction. If no beam in other direction, then enter 0 in that direction. Same way all column number in grid and beam number around that column has to be enter. Third, same type grid is seen. In that enter member length in yellow cell in meter. Fourth, enter data for stiffness of columns, like concrete mix, FCK, width of column in meter, depth of column in meter, length of column in meter. This data will be according to column number on the second grid. Fifth is accidental eccentricity and torsion, in that enter building dimension perpendicular to X direction in BI, in meter. It is 6 meter. Next enter lateral seismic load Q in kilonewton in yellow cell in X direction. In my case, it is 0.948 kilonewton for ground floor. In the same way you have to enter building dimension perpendicular to Y direction in BI, in meter. It is 9 meter. Next you have to enter lateral seismic load Q in kilonewton in yellow cell in Y direction. In my case, it is 1.161 kilonewton for ground floor. Next click on output button. Your final load at node due to earthquake in X, final load at node due to eccentricity and torsion in X, final load at node due to earthquake in Y, final load at node due to eccentricity and torsion in Y is ready. Next, click on Add to Schedule button. Your nodal load on that floor will be displayed on earthquake nodal load schedule sheet. In this way enter member number, UDL, point load, length of member, total number of member, column number, and beam number in first grid, member length in second grid, stiffness of column data, accidental eccentricity, and torsion data for every particular floor. Then click on Output button every time. Save this result every time in earthquake nodal load schedule sheet by click on Add to Schedule button. After that enter this final nodal load in input data sheet in node load heading in X force, Y force, Z force, X moment, Y moment, Z moment column. Do analysis by clicking Analysis button. This result will be used in load combination sheet. In that sheet click on respective button like member end forces, earthquake load in positive X direction, negative X direction, positive Z direction and negative Z direction. Fifth sheet is wind load analysis. In this sheet enter data in light yellow cells. First enter number of story. It is 9 in my case, including first floor to terrace floor, ground floor. Second enter type of building. I choose all general buildings and structures. You can choose any one suitable to the structure. Third enter location name. I choose Surat. In that you have to choose city name in which structure is located. Fourth enter building category. I choose category 3, average height of numerous surrounding structure is up to 10 meter. You can choose any one suitable to the structure. Fifth enter topography. I choose plane with upwind slope less than 3 degree. You can select any one suitable to the structure. Sixth enter floor area. I have 9 meter in horizontal X and 6 meter in vertical Y direction. You have to enter as per your building plan dimension. Seventh enter wall area in meter square. In that enter perpendicular to X direction length of the structure and height of the structure for X direction wind load and minus X direction wind load. It is 6 meter by 24 meter. In the same way for Z direction wind load, you have to enter perpendicular to Z direction length of the structure and height of the structure. It is 9 meter by 24 meter. Eighth enter opening area. In that enter total opening area such as door, window, ventilation etc. In my case every floor 2 window in X direction of 2 meter square, so total 32 meter square for 8th floor, and 48 meter square for Y direction. Ninth wind load on face of. In that you have to enter perpendicular length of the structure in which wind is flow. It is 6 for X direction and 9 for Y direction. 10th CF. In that, if given figure 4a, use figure 4a, and if given figure 4b, use figure 4b. In that for A by B, and H by B, CF find out and enter in light yellow cell. In my case it is 1.4. 11th CF, in that maximum of CF, and CPE minus CPI, is find out and enter in light yellow cell. It is 1.5. 12th row of column on that face. In that enter number of column on that face and on that floor. It is 3 column for X direction wind and 4 column for Y direction wind. 13th parapet wall height, ground floor height, typical floor height and beam overall depth in meter. It is 1 meter, 3 meter, 3 meter, and 0.45 meter respectively. In that you have to enter your structure respective data. Next is click on Reset or Clear button. Your previous data will be blank. Next is click on Story Level button. Your number of story will be displayed. 14th story name. In that enter name of the story such as ground floor, first floor to 7th floor and terrace floor in light yellow cell. 15th story height. In that enter height of that particular story in light yellow cell. 16th wind load on face of in meter. In that enter perpendicular to wind load direction length of that floor of the structure. It is 9 meter for Y direction wind and 6 meter for X direction wind. 17th row of column on that face in number. In that enter number of column of that floor and on that face. It is 3 for X direction wind and 4 for Y direction wind. 18th projected height in meter. In that enter addition of half height of above floor and half height of below floor for that floor. It is 1.5 for terrace and ground floor and 3 for typical floor. Next is save the sheet. You will get the force at each story level, nodal point load in kilonewton and the force at each story level load in kilonewton. Copy and paste and save this data in next column. Same procedure is done for Y direction wind also. Next, you have to enter particular floor wind load in earthquake nodal load sheet, and you will get final load at node due to wind load in X, X, Z, and -Z direction. Next is click on Add to Schedule button. Your nodal load on that floor will be displayed on earthquake nodal load schedule sheet. In this way for every floor you can get final nodal load. After that you have to enter this nodal load in input data sheet in node load heading in X force, Y force, Z force, X moment, Y moment, Z moment column. Do analysis by clicking Analysis button. This result will be used in load combination sheet. In that sheet click on respective button like member end forces, wind load in positive X direction, negative X direction, positive Z direction and negative Z direction. Sixth sheet is stability indices. In that grid is seen. First enter length of member in yellow cell of particular floor according to grid. Keep in mind that for X direction wind load and earthquake load analysis only X direction beam length in meter is to be enter, and for Z direction beam length only is to be enter. You have to enter that number of total beam only. Second number of story. In that enter total number of stories. It is 9. Third beam size. In that enter width and height of beam in meter. It is 0.23 meter and 0.45 meter. Fourth column size. In that enter width and length of column in meter. It is 0.23 meter and 0.35 meter. Fifth beam concrete grade and column concrete grade. In that enter concrete grade of beam and column. Here I use 30. Sixth total number of beam. In that enter total number of beam in X direction for X direction wind and earthquake load. It is 9 for X direction. Similarly number of beam in Z direction for Z direction wind and earthquake load. It is 8 for Z direction. Seventh total number of column. In that enter total number of column of that floor. It is 12 in my case. You have to enter your structure's appropriate data. Next click on Clear or Reset button. Your previous data will be cleared. Next click on Story button. Your number of story will be displayed. Eighth height of story in meter. In that particular story height has to be entered. It is 3 meter. Next click on Stiffness button of particular floor. You will get the stiffness of that floor. Same way if data and grid change on other floor, for every floor, changed grid is created and other changed data will be entered. Click on Next Story Stiffness button. You will get that particular story stiffness. In this way click on every floor stiffness button. So you will get every floor stiffness. Next save the sheet. You will get drift and displacement due to wind, drift, and displacement due to seismic loads and stability indices. Next click on Safe or Unsafe button. If structure is safe due to wind, then safe will be displayed, otherwise unsafe will be displayed. Next click on second safe or unsafe button. You will get every floor is safe or unsafe due to seismic loads. Next click on type button. You will get every floor is sway or no sway due to seismic weight. If get unsafe or sway type building. Change the concrete grade or size of beam or column and save the sheet until get safe and no sway type building. Seventh sheet is load combination. First click on reset or clear button. Your previous data will be cleared. Same way click on all reset or clear button. Your all previous data will be cleared. Second click on member end forces for dead load button for dead load analysis. Third click on member end forces for live load button for live load analysis. Fourth click on member end forces for earthquake load in X direction button for earthquake load in X direction analysis. Fifth click on member end forces for earthquake load in -X direction button for earthquake load in -X direction analysis. Sixth click on member end forces for earthquake load in Z direction button for earthquake load in Z direction analysis. Seventh click on member end forces for earthquake load in -Z direction button for earthquake load in -Z direction analysis. Eighth click on member end forces for wind load in X direction button for wind load in X direction analysis. Ninth click on member end forces for wind load in -X direction button for wind load in -X direction analysis. 10th click on member end forces for wind load in Z direction button for wind load in Z direction analysis. 11th click on member end forces for wind load in -Z direction button for wind load in -Z direction analysis. 12th click on load combination 1, 1.5 dead load plus 1.5 live load button. 13th click on load combination 2, 1.2 dead load plus 1.2 live load plus 1.2 earthquake load in X direction button. 14th click on load combination 3, 1.2 dead load plus 1.2 live load plus 1.2 earthquake load in -X direction button. 15th click on load combination 4, 1.2 dead load plus 1.2 live load plus 1.2 earthquake load in Z direction button. 16th click on load combination 5, 1.2 dead load plus 1.2 live load plus 1.2 earthquake load in -Z direction button. 17th click on load combination 6, 1.5 dead load plus 1.5 earthquake load in X direction button. 18th click on load combination 7, 1.5 dead load plus 1.5 earthquake load in -X direction button. 19th click on load combination 8, 1.5 dead load plus 1.5 earthquake load in Z direction button. 20th click on load combination 9, 1.5 dead load plus 1.5 earthquake load in -Z direction button. 21st click on load combination 10, 0.9 dead load plus 1.5 earthquake load in X direction button. 22nd click on load combination 11, 0.9 dead load plus 1.5 earthquake load in -X direction button. 23rd click on load combination 12, 0.9 dead load plus 1.5 earthquake load in Z direction button. 24th click on load combination 13, 0.9 dead load plus 1.5 earthquake load in -Z direction button. 25th click on load combination 14, 1.2 dead load plus 1.2 live load plus 1.2 wind load in X direction button. 26th click on load combination 15, 1.2 dead load plus 1.2 live load plus 1.2 wind load in -X direction button. 27th click on load combination 16, 1.2 dead load plus 1.2 live load plus 1.2 wind load in Z direction button. 28th click on load combination 17, 1.2 dead load plus 1.2 live load plus 1.2 wind load in -Z direction button. 29th click on load combination 18, 1.5 dead load plus 1.5 wind load in X direction button. 30th click on load combination 19, 1.5 dead load plus 1.5 wind load in -X direction button. 31st click on load combination 20, 1.5 dead load plus 1.5 wind load in Z direction button. 30-second click on load combination 21, 1.5 dead load plus 1.5 wind load in minus Z direction button. Next click on maximum of all combination button. You will get beam number, factored moment, factored axial force, factored reaction, and unfactored point load and distance of that point load from left and factored uniformly distributed load of that beam. You will also get column number, axial factored load, factored moment MZ, factored moment MY, shear force in Z or X direction HUX, shear force in Y direction HUY of that column. This result will use for beam design and column design respectively. Similarly, axial unfactored load, unfactored moment MZ, unfactored moment MY, shear force in Z or X direction HUX, shear force in Y direction HUY will use for footing design. Eighth sheet is ductile beam. In that you have to enter data in yellow cell. First of all, enter total number of span for continuous beam. In my case, it is 2 type, 3 span, and 2 span. Second, select beam number from given menu, that is to be designed. Third, select beam type whether it is rectangular beam, T-beam, or L-beam. Next, click on enter data button. You will get factored moment in kilonewton meter, factored axial force in kilonewton, factored reaction in kilonewton, unfactored point load in kilonewton, its distance from left, factored UDL in kilonewton per meter and span length in meter. Fourth, enter support width in millimeter in yellow cell. It is 230 mm. Fifth, enter slab thickness in millimeter, and center to center distance of that beam spaced in meter. Means, half of slab length for L beam, and half of both side slab length for T beam. Sixth, enter concrete grade of beam, 20, steel grade of beam, 415, diameter of bar used in millimeter, 12, layer of bar, 1, stirrups diameter use in millimeter, 8, you can select any option suitable for that beam. Seventh, enter beam width B, 230 mm, and beam depth D, 450 mm as required. Next, save the sheet. You will get whether beam is singly reinforced or doubly reinforced. Next, you get top area of steel required in millimeter square and bottom area of steel required in millimeter square. Eighth, enter appropriate top diameter of bar provided in yellow cell. You get the number of bar provided for straight bar and 2 type of curtailment bar. If moment of resistance display is not okay, change diameter of bar provided, beam depth or concrete grade until moment of resistance display is okay. Next, same procedure is due for bottom bar. Next, see development length check. In that, if anything is unsafe, change diameter of bar used or number of bar provided. Sometime for small span get this check is unsafe. Ignore it for small span. Next, see shear check. In that shear check, stirrups has to be safe. Next, see curtailment check. In that, minimum center to center spacing stirrups at mid span to be provided in yellow cell in millimeter as seen in shear check. Note that if left support and right support use minimum stirrup spacing, then in center portion also use same minimum spacing. Next, see deflection check. In that, check must be safe. Next is cracking check or spacing of bars check. In that, bottom bar and top bar spacing must be safe. Next is check for general ductility requirements. In that, factored axial stress, minimum width of beam, B divided by D, D shall be less than or equal to 0.25 time clear length of beam, minimum 2 bars at top and 2 bars at bottom shall be provided, minimum steel ratio, maximum steel ratio, at support, positive area of steel shall be greater than or equal to 0.5 time negative area of steel, along the length of the beam, anchorage length of support bars at top and bottom, bars provided at column face must extend for a distance of 2D or L by 4. In the span, at lap, link spacing shall be less than or equal to 150 mm, lap length shall be greater than development length, lap not provided at joint and at distance 2D from face of column, lap bar shall less than 50% bar at any one section, provided center to center spacing stirrups in remaining mid-span. This all check must be OK. Next, if all check is safe or OK, click on Add to Schedule button. Your result like top and bottom reinforcement detail, stirrups detail will add in ductile beam schedule sheet. Same procedure is follow for other span also. Next you will get concrete quantity, total weight of particular diameter of reinforcement and total weight of that reinforcement for that beam required in ductile beam schedule sheet. Ninth sheet is column design. In that enter data in yellow cell. First of all enter column number from given menu, that is to be design. Next click on enter data button. You will get axial factored load in kilonewton, factored moment mz in kilonewton meter, factored moment my or mx, in kilonewton meter, shear force in z or x, shear force in y, floor height in millimeter. Second enter size of column width and depth in millimeter, size of beam width and depth excluding slab thickness in millimeter, slab thickness in millimeter, type of design either ductile design or normal design. Third enter concrete grade FCK, 20, steel grade FY, 415, longitudinal bar diameter used, 12, reinforcement type, 4-side reinforcement. Keep in mind that if you change reinforcement type from 2-side reinforcement to 4-side reinforcement or from 4-side reinforcement to 2-type reinforcement, then again click on enter data button and save the sheet, so you will get required area of steel for that type of reinforcement. You can select appropriate option suitable for that column. Next save the sheet. You will get required area of steel in millimeters square. Fourth enter diameter of bar and number of bar and save sheet such that area is higher than required so design is safe and section is OK for flexure and compression. If section is not OK for flexure and compression or unsafe, then change diameter of bar and number of bar or section of column or grade of concrete. So section is OK for flexure and compression. Fifth enter diameter of bar and number of bar provided on one face and save sheet. So you can check that design is safe or not safe for shear. Sixth enter use ties diameter, 8, and save sheet, so you can see that it is OK or not OK. Seventh enter general ties provided spacing as per required spacing. Eighth enter ties diameter used in confining zone, 8, and save sheet. Ninth enter confining zone ties provided spacing as per required spacing. 10th as seen in drawing, enter number of internal bar on both face of column and save sheet. So you will get either internal extra ties not required and open ties is sufficient or extra closed or open ties required. Next is click on add schedule button. So your result data will be added in column schedule sheet. In this way all column shall be designed and add in column schedule sheet. In column schedule sheet you can see column number, size of column, main steel diameter and number, general ties diameter and spacing, LO distance, confining zone ties diameter and spacing, ties diameter and spacing at beam column joint, ties at lap, concrete grade, lap length. You can also see weight of particular diameter reinforcement and concrete quantity required for that column. 10th sheet is footing design. In that enter data in yellow cell. First of all enter footing number from given menu, that is to be design. Next click on enter data button. You will get column size, unfactored service load, unfactored service moment mx, unfactored service moment my, horizontal thrust along longer side of column, column reinforcement, number of reinforcement and diameter of reinforcement, concrete grade of column. Second enter steel grade of column, concrete grade of footing, steel grade of footing, allowable bearing pressure in kilopascal and type of footing, slope footing. You can select appropriate option suitable for that footing. Third enter overall depth of footing in millimeter, depth at edge of footing in millimeter, appropriate width of footing in yellow cell in meter and save the sheet. Keep in mind that, width of footing shall be such that area of footing provided is some more than required area of footing. Also keep in mind that if two footings width and length is coincide with each other, then footing shall be designed as combined footing. Fourth, enter width of footing B in meters such that P maximum should be less than allowable bearing pressure and near to allowable bearing pressure. And P minimum should be greater than 0. It is the final width and length of footing in meter. In my case it is 2.61 by 2.67 meter. Fifth, enter try overall depth in millimeter and diameter of bar in yellow cell. Save the sheet. Sixth, change every time overall depth of footing in millimeters such that getting resistance to horizontal load, one-way shear, two-way shear, transfer of load from column to footing, weight of footing, development length, and cracking check is safe. If any one of them is unsafe, change overall depth of footing and bring it safe. Next, if all check is safe, click on Add to Schedule button. Your result data will be added in footing schedule sheet. In footing schedule sheet, you can see footing number, size of footing B and L, overall depth in millimeter, depth at edge in millimeter, steel parallel to shorter side and longer side, diameter and number, size of bed block PCC width and length and thickness in millimeter, top dowel length in millimeter, footing type, and concrete grade. You will also get weight of particular diameter reinforcement used in footing in kilogram and concrete quantity in meter cube.